I have had a question already on 2.5 about the first problem on the homework, as a matter of fact. And that problem, it talks about a petri dish, and it tells you that the density curve is expressed by y equals x over 2. And for part A, it just says to graph the density curve between 0 and 2. So we have this constraint that we want to focus on. And you can think of x over 2 as simply 1/2 x, which means we have a y-intercept of 0 and a slope of 1/2. So we get this curve, or in this case just a line, that looks like this. So that's your density curve graph. I'm going to label the axis. So there we have from 0 to 2. And that's all you had to do for part A, was to graph that curve. For part B, you gotta love the dogs. It says show that the area under the curve, so that's going to be this area right here, is going to be represented by x squared over 4. So when we think about this density curve, we have a value x, and our output is x over 2. So our x value defines the width of the triangular region here, and then the y value defines the height of the triangular region. So the area formula for a triangle is 1/2 base times height, and in our case we have the base is x, the height is x over 2, and when we simplify that, we get x squared over 4. So there's our area formula for this density curve. So this represents 100% of the data. I apologize for these dogs, really. Then for part C, it says to find what percentages at most 1 inch from the center of the plate. So we're looking at x is less than or equal to 1. So what we can do is take our area curve, or our area formula, which is x squared over 4. We substitute in 1, and this is going to give us the area from 1 over to the left of 1, and we get 1/4, which we know to be 0.25, so that is 25%. Part D, between 0.25 and 1.5. So here we're going to do a range. What we have to first figure out is 0.25, put it into our area formula, and then we are going to compute that. Carla found her vases. We're going to compute that. It's 0.25 squared, which is 0.0625 over 4, and when we divide that by 4, we get 0.15625. There's a 0 in there, sorry. And then we also have to figure out the other value, which is 1.5. Now remember, these values show everything to the left of that given point. So everything to the left of 0.25 is roughly 1.5625%. That's the percentage of the values that are left of that. Then we want to also figure out what is to the left of 1.5. So we do 1.5 squared, which is 3.375. We divide that by 4, and we get 0.84375, which is approximately 84.375%. So looking at our triangle that we've drawn above, 0.25 is right here. That's going to cover this area, and then 1.5 is right here, and that's going to cover this area. So we have an overlap of this region right here. So what we want to do is take the 84 0.375 minus 1.5625. And when we figure that up, we get 84.375 minus 1.5625, 82.8125%. So that's the percentage of the range that falls between 0.25 inches and 1.5 inches. And then finally we have part E that asks you to find where X is going to be greater than 0.75. So we're going to do the same thing. Remember, when we compute this using the area formula, it gives us everything to the left. So let's figure that out first. We get 0.75 quantity squared over 4. And I need to type that in. Divided by 4. Well, we get 0.140625. Don't have to use that many decimal places. I'm just writing down what I see on the calculator here. So that is the area to the left of 0.75. What we want is the area to the right of 0.75. So all we have to do is 1, because we know that's the total area under the curve, minus 0.140625, and we get if I could type 0.859375, which is 85.9375%. So I can see where the confusion might have been on that problem, but really if you come up with the curve, and I know that it's misleading to hear the word curve and end up with a straight line, but technically in mathematics, any kind of line in a graph can be considered a curve. A curve does not mean that it has a inflection point that generates a rounded curve edge per se, but that's how you would do this problem. And then for problem number 2, I think it's very similar to that. And then the remainder of the problems just simply use the normal curve. But we will plan on having a Zoom meeting tomorrow. I would say probably around 1 o'clock. I will send out a message tomorrow for sure when I know. I've got to see what I have going on. But I hope that this was helpful with the first problem on the homework, and I hope you guys are doing great. I will talk to you tomorrow.